Hello students, in our previous video we studied about the LENARD'S experimental study of photoelectric effect. LENARD'S experimental study of photoelectric effect. In that situation we observed the space charge, next one is the saturation current, and next one is the stopping potential. These are the we observed in that video. Here from that experiment, what are the conclusions? What are the observations? What are the observations from that LENARD'S experimental study? LENARD'S experimental study. In that one, first one is effect of intensity of radiation. That is the effect of intensity of incident radiation on photoelectric current. On photoelectric current. Effect of intensity of incident radiation on photoelectric current. So here intensity. First of all, what is intensity? Intensity means that is nothing but the power. Intensity means that is the power. Yes. This is the power. If you observe our bulbs, 60 watts bulb, 40 watts bulb, yes. So here 40 watts bulb, 60 watts bulb, next 80 watts bulb, 100 watts bulb, means here this watt, that is nothing but the power. That one indicates the intensity. That one indicates the intensity. So here in this situation, we kept the frequency remains constant. Frequency remains constant, and photoelectric metal is also constant. Photoelectric surface or maybe photoelectric metal, that is also constant. Same metal we are using throughout the experiment. In this situation, here power is changed. Power changes, that is the intensity changes. Frequency remains constant. Frequency remains constant means, so we are using the same color bulb, but intensities are changes. First one, something I am taking, this one is the yellow color bulb, 40 watts yellow color bulb, 40 watts yellow color bulb, next 60 watts yellow color bulb, 80 watts yellow color bulb. So all are the here frequency remains constant, but that intensity changes, intensity is increases. Here photoelectric metal is also constant, that is the same metal we are using, okay. In this situation, if your intensity of the incident radiation is increases, photoelectric current value is also increases. From that experiment, what is the conclusion here? When this intensity is increases, then that means intensity increases means first one we are using the 40 watts bulb, that will give this some radiation. Next 60 watts bulb, that will give this some radiation. 80 watts bulb. In that situation, here when that intensity value is increases, this photoelectric current value is also increases. From the first one, we observed when the intensity of the incident radiation increases, photoelectric current value is also increases. Why that one is increases? We will discuss that one also. Okay. First, what is the first conclusion here? Yes. Okay. Here this is the intensity. Intensity is taken on the y-axis, and current value is, yes. Here current value is taken, okay, where independent physical quantity is the I, sir, okay, capital I. Intensity is taken on the x-axis and photoelectric current is taken on the y-axis. So this is the independent physical quantity, that is in our hand. That's why independent physical quantities are always taken on the x-axis, okay. So when this intensity is increases, something, this is the I1 intensity, here this is I2 and this one is the I3. Corresponding current values, this is the I1 current and I2 current and this is the I3 current. So when intensity is equal to, I1, in the situation, photoelectric current is equal to small I1. When intensity is equal to I2, photoelectric current is I2, small I2. Current intensity is equal to I3, current is equal to I3. Here, if you add all these points, we are getting a straight line. This one is passing through the origin. This is passing through the origin. So observe this graph. Intensity increases, photoelectric current is also increases. Here, which one is kept constant? Frequency remains constant. Frequency means color of the radiation. Color of the radiation. At the same time, that photoelectric surface, photoelectric metal, that one is also kept constant. In that situation, with respect to the intensity of incident radiation, photoelectric current is increases. What is the conclusion from this graph? Photoelectric current is increases with respect to the intensity of incident radiation. Intensity of incident radiation. Next one is, right, next one, observe, right, next one. So effect, this is the second one. Effect of potential on photoelectric current. Effect of potential on photoelectric current. Okay. So here is also frequency remains constant. Frequency, this is remains constant. And photoelectric current is also kept constant. Photoelectric metal, not current. Photoelectric metal. Photoelectric metal, this is also kept constant. Here, how to vary the current value with respect to the voltage for different intensities, I1, I2, I3 and so on. How to vary the current value with respect to the potential difference or applied potential for different intensities of the light. Here generally observe, when this voltage value is increases, means the potential difference between the electrodes is increases, photoelectric current is also increases, that is the positive voltage. Yes, I am giving you more clarity. Yes, observe. Here positive voltage in between the electrodes is increases. Then photoelectric current value is also increases. After the certain potential, that current value becomes a constant. We are calling that current is saturated current. We are using that word, saturated current. Okay. So here we are doing the same experiment for the different intensities of the radiations. Okay. First I am using the I1 intensity of the radiation, means something 40 watts bulb we are using. 40 watts yellow color bulb we are using. Why? Because frequency is also kept constant. Photoelectric metal kept constant. When we are using the 40 watts bulb, 40 watts yellow color radiation, in that situation, for different intensities of, for different voltages, so observe this one. Here, when this voltage value is, that is the independent physical quantity, voltage is taken on the x-axis and photoelectric current is taken on the y-axis. For I1 intensity of the radiation, here when this voltage, positive voltage is increases, photoelectric current is also increases. After the particular voltage, that current value becomes a constant, that is the saturated current. When negative voltage is increases with respect to the that emitter, collector negative voltage is increases, then current value gradually decreases, and at a particular voltage, at a particular negative voltage, the current value becomes zero. That voltage is called as that is the stopping potential or stopping voltage, stopping potential. Okay, this is for the I1 intensity of the radiation. Okay, yes. This is for the I1 intensity of the radiation. Next one, Same frequency, same photoelectric metal, but I2 intensity of the light we are using. I2 intensity of the light, that is the yellow color. How much this intensity? Means that is equal to something 60 watts. Here previous one is the 40 watts, right now 60 watts. Then what happened? Photoelectric current is increases, that is the saturation current is also increases. So here we get the graph like this for the different voltages of the, for the different applied voltages, we get the graph like this. This is the saturation current. Here this is the I2 intensity of the light. First one is the I1 intensity of the light. Second one is the I2 intensity of the light. Next one, same process for the third intensity, that is the I3 intensity of the light. Here I3 is more than that of the I2 and more than that of the I1. So means from this one observe, when this intensity value is increases, saturation current is also increases. From the first one also we conclude that with respect to the intensity of the incident radiation, photoelectric current is increases. Photoelectric current is increases. Same thing is happened here. So here from this graph, what is the observations? Observe. Whatever it may be the intensities of the incident radiation, but stopping potential is same. Whatever it may be the intensities of the incident radiation, stopping potential is same. Means here stopping potential is independent on the intensity of the incident radiation. Conclusion. First one, stopping potential, this is the minus V naught, is independent on intensity of incident radiation. Intensity of incident radiation. Yes. We are using the different intensities of the light, but frequency remains constant. In that situation, here that is stopping potential, whatever it may be the intensity, stopping potential is same. So that is the first conclusion. Stopping potential is independent on intensity of incident radiation. What about the second one? Here same thing, previous one only. So with respect to the intensity of the incident radiation, photoelectric current, that is the saturation current, is increases. With respect to the intensity of incident radiation, this saturation current is also increases. These are the conclusions from the second one. So what is the second one? Effect of potential on effect of potential on photoelectric current. Here what is the conclusions from this one? Here stopping potential is independent on the intensity of incident radiation. But saturation photoelectric current is increases with respect to the intensity of incident radiation. Those are the two conclusions from the second concept. Okay, next one, third one. Effect of frequency of incident radiation on photoelectric current. Effect of frequency of incident radiation on photoelectric current. Here frequency changes, but intensity constant. Here intensity I remains constant. Small I is the photoelectric current, remember this one. Small I is the photoelectric current, capital I is the intensity of incident radiation. So capital I means this is the intensity. Intensity kept constant. This is the intensity kept constant, but frequency changes. What is that frequency? I will discuss that one also. Here is also photoelectric metal constant. Photoelectric metal constant. First one, intensity of the incident radiation, that one kept constant. Second one is the photoelectric metal kept constant, but different frequencies of the light we are using. Yes, different frequencies. First of all, what is frequency? Frequency means that one represents the color only. Frequency means that one represents the color. Here intensity kept constant. Yes, intensity kept constant. Something we are using the 40 watts bulb. 40 watts, first one yellow color bulb, yellow color radiation. Second one is the green color radiation, green color radiation. Third one is the red color radiation. Something. Here frequencies are changes. Frequency means a color. Color changing, but all the radiations have the same intensity. All the radiations have the same intensity. In that situation, how to vary that photoelectric current? How to vary that photoelectric current? So here, yes, same thing observe. Yes, here I have drawn the graph. Yes, observe. Here, this is the x-axis. On the x-axis, we are taking the voltage, and on the y-axis, we are taking the photoelectric current. On the y-axis, we are taking the photoelectric current. So here, observe for different frequencies and same intensity. Different frequencies, same intensity, same wattage of the bulbs, same intensity of the bulbs. Then what happened? With respect to the voltage, here observe, with respect to the voltage, photoelectric current is increases, no doubt at all. Why? Because when the positive voltage in between the anode and the cathode, that one is increases, photoelectric current is increases, and that one approaches the one constant value we are calling, that is the saturation current. So here is also same, we are getting this some saturation current like this. For the frequency nu1, for the frequency nu1, yes, this is the for the frequency nu1. This is the stopping potential for the first frequency. Therefore, minus V01. This is the frequency nu1. Frequency nu1. This is the stopping potential. For this frequency, this is the stopping potential. Next. For the next same intensity, but next frequency is changing. Frequency is changing. So in that situation, frequency is changing, but intensity is same. Intensity is photoelectric current depends upon the intensity. So photoelectric current value not changes. In that situation, stopping potential is changing. Here this is for the second frequency, nu2 frequency, stopping potential is equal to minus V02. For the third one, for the third frequency, so here we are getting the graph like this. This is for the minus V03. For the frequency nu3, means here nu3 is more than that of the nu2, is more than that of the nu1. When this frequency is increases, the stopping potential is also increases. Try to observe. When this frequency value is increases, stopping potential is also increases. Here intensity kept constant, but different colors of the radiation we are using. Different colors of the radiation we are using. Here saturation current, that is also constant. Why? Because intensity not changes. Intensity not changes means photoelectric current not changes. But stopping potential values are different for the different frequencies. For the different frequencies. So from this graph, what are the conclusions? Here conclusions. Conclusions. First one. Here the stopping potential is different for different frequencies. Stopping potential V0 or minus V0 is different, or maybe stopping potential is increases with respect to the frequency of incident radiation. Frequency of incident radiation. When frequency of the incident radiation increases, that stopping potential is also increases. When frequency of the radiation decreases, stopping potential decreases. Next, second one. The photoelectric current or saturated current, that one does not depends upon the frequency. Photoelectric current does not depends upon frequency of radiation or frequency of radiation or frequency. So what are the conclusions from the third part? So first one, here in this one, first one, stopping potential is increases with respect to the frequency of incident radiation. Means when frequency of the radiation increases, stopping potential is also increases. Second one is the photoelectric current does not depend upon the frequency. Whatever it may be the frequency, observe that saturation current does not depend upon the frequency. All the frequencies have the same saturated current. Intensity is same. Here intensity kept constant, at the same time photoelectric current, photoelectric metal, the surface is also kept constant. So these are the conclusions from the third one. Next, fourth one is next one, variation of stopping potential with frequency of incident light. Variation of stopping potential with respect to the intensity of incident light. Here for different metals, means here that photoelectric metal is changes, photoelectric metal, that one is changes, not constant. This is the change right now, this one is the change right now. Frequency is also changes. Here frequency is also changes. Which one is constant? Intensity is constant. Here intensity is constant. In that situation, if you draw the graph in between the stopping potential and the frequency, yes, here this is the x-axis and this one is the y-axis. For different metals, I am using the what? Photoelectric metal is changes. Something we are using, something copper. First one we are using the copper. So in that situation, here we are getting the graph. Yes. Here frequency is taken on the x-axis and stopping potential is taken on the y-axis. Here we are getting the graph. For the first metal we are getting the graph like this. Next, if the metal surface is changes, here we are getting the graph like this. Something third metal, okay, this is the first metal. For the first metal, second metal, third metal, fourth metal, something. So means observe here, this one have the stopping potential, that is the minus V01. For the second metal, this one is the, yes, here this one is the V02, minus V02. For the third one, this one is the minus V03. Here observe, these are nothing but the threshold frequencies. Nu01, this is the Nu02 and Nu03, and this is the Nu04. For different metals, they have the different threshold frequencies. For different metals, they have the different threshold frequencies. So from this graph, what is the conclusion? Different metals, they have the different threshold frequencies. So these are the observations from the LENARD'S experiment. Next one is the, yes, laws of the photoelectric effect. Laws, LAWS, not LOSS. Okay, laws of the photoelectric effect. Yes. Next one is the laws of the photoelectric effect. So in this one, first one, if the frequency of the radiation is, if the incident radiation, that one have the certain frequency, that value is more than that of the threshold frequency, then only photoelectric emission takes place. Means incident radiation value, that is the frequency of the incident radiation, is more than that of the threshold frequency, then only photoelectric emission takes place. Then only photoelectric emission takes place. First one, what is the first law? Here from the those observations, so we form the laws. First one, if the frequency of the incident radiation is more than that of the threshold frequency, then only photoelectric emission takes place. Second one is photoelectric current is I value is increases with respect to the intensity of incident radiation. Here capital I means intensity of the incident radiation. Small I, this is the photoelectric current. Photoelectric current is increases with respect to the intensity of incident radiation. With respect to the intensity of incident radiation. Next one, third one, stopping potential. Yes. Stopping potential, that is the V naught. Stopping potential, that is the minus V naught. Okay, minus V naught. Stopping potential is independent on intensity of incident radiation. Stopping potential, that is the minus V naught, that is independent on intensity of the radiation. Whatever it may be the intensity of incident radiation, the stopping potential is same. We are getting the graph like this. Sorry. So we are getting the graph like this. Here intensity is increases, but stopping potential is same. Stopping potential is same. So here stopping potential is independent on intensity of incident radiation. Intensity of incident radiation. Capital I. Next one, third one, fourth one. What is the fourth one? Yes, frequency. Yes, observe this one. That is the frequency of the incident radiation. Yes, saturation current, that is the I, is independent on saturation current is independent on frequency of the incident radiation. Frequency of incident radiation. Yes, observe this one. Photoelectric current is the saturated current, that is independent on the frequency of incident radiation. For different frequencies of the radiation, we are getting the same saturation current but different stopping potentials. For different stopping potential. Next, one point. So here that frequency is frequency of radiation. Frequency of radiation, or maybe incident radiation, frequency of incident radiation. Yes, frequency of the incident radiation, not the frequency. What formation is not correct. Yes, observe. Stopping potential. Stopping potential is depends on frequency of incident radiation. Frequency of incident radiation. Frequency of incident radiation. Stopping potential is changes. When frequency is increases, stopping potential is also increases. You get the graph like this. For the same intensity, stopping the saturation current is same. For different frequencies of the light. Here this is the minus mu naught 1, minus mu naught V naught 2, minus V naught 3. These are the stopping potential. So stopping potential is depends on the frequency of incident radiation. So that stopping potential is independent on the intensity of incident radiation. Intensity of incident radiation. Yes. Next one, sixth one. Kinetic energy of emitted electrons. Kinetic energy of emitted electrons. Kinetic energy of emitted electrons is increases with respect to the frequency of radiation. With respect to the frequency of radiation. Yes, observe. Already in case of the LENARD'S experimental study, we wrote one equation. E V naught is equal to half m V max square. So here stopping potential is increases. When stopping potential is increases, then kinetic energy is also increases. That's why writing kinetic energy of the emitted electrons is increases with respect to the frequency of radiation. When frequency is increases, stopping potential increases. When stopping potential increases, kinetic energy of the emitted electrons is also increases. So last point here, seventh one, is the instantaneous process. Instantaneous process. So this one is the instantaneous process, means when radiation is instant on the photoelectric metal, then electrons are emitted from it. So here time taken between the incident of the incident radiation and emission of the electrons, that one is nearly is in the order of the 10 to the power minus 9 seconds. Very less time. When radiation is incident on the photoelectric metal, electrons are emitted from it. Okay, that's why we are calling that the instantaneous process. Photoelectric effect is the instantaneous process. Okay, these are the laws of the photoelectric effect. What is the first one? Frequency of the incident radiation is more than that of the threshold frequency, then photoelectric emission takes place. Second one is the photoelectric current increases with the intensity of incident radiation. Third one, stopping potential is independent on the intensity of incident radiation. Intensity increases also or maybe decreases also, stopping potential is same. Fourth one, photoelectric current is independent on the frequency of the incident radiation. Photoelectric current, not the photoelectric, here saturation current. Correct, what is the saturation current? Saturation current is independent on the frequency of incident radiation. Next one is the stopping potential is depend on the frequency of the incident radiation. How that one is dependent? Frequency increases, stopping potential increases. Next, kinetic energy of the emitted electrons is increases with respect to the frequency of incident radiation. Already we told here. Frequency increases means stopping potential increases. Stopping potential increases means kinetic energy of the emitted electrons is also increases. Last one is this is the photoelectric effect is the instantaneous process. So when light is incident on the photoelectric metal, then electrons are emitted from it. Okay, these are the laws of the photoelectric emission, photoelectric effect. So generally in NCERT textbook they given the only 4. We are elaborated that one. Okay, we are elaborated that one. Okay, yes. Next one is the failures of the wave nature of light to explain about the photoelectric effect. What are the failures to explain the photoelectric effect? By using the wave nature of the light. Actually dual nature, we are discussing about the dual nature of light, or second one is the dual nature of the radiation and matter. Radiation means light only. Okay, here this photoelectric effect, to explain the photoelectric effect, wave nature of the light is failed. What are those failures? So first one, try to observe here. First one, according to the wave nature of the light, wave theory, or maybe wave nature of the light. Generally we are using the word wave theory. So more intensity means more energy. More intensity means more energy. More intensity means more energy. So if you observe here, actually here intensity is also, that is depends upon the, intensity is directly proportional to the square of the amplitude. Here we are using 2 waves. Try to observe, this is the first wave, this is the second wave, and this is the third wave. So here this third wave have the more amplitude, so that one have the more energy. So here intensity means when intensity is increases, energy is also increases. But practically observed in case of the second observation, I think. So in that one we are getting the graph like this. Different intensities of the light we are using. We are getting the same stopping potential, means all the emitted electrons, those are moving with the same kinetic energy. His stopping potential is same, means all the emitted electrons, they have the same stopping potential, means all the emitted electrons are moving with the same kinetic energy. So energy, according to wave nature of the light, when intensity increases, energy is increases. But practically what happened? All the electrons have the same kinetic energy, means all the emitted electrons have the same energy. So means that is the first failure. That is the first failure. Try to observe, don't by heart it. Try to observe. So according to wave nature, according to wave theory, intensity increases means energy is also increases. Intensity increases means energy is also increases. But practically that is, we are not observing that one practically. In practically, we are observing this one. Different intensities of the light we are using. In that situation, all the emitted electrons, they have the same kinetic energy. So means that is a failure. That is a failure of the wave nature of the light to explain about the photoelectric effect. Second one. In case of the wave theory, we observe the wavefronts. The locus of all the points which are having this, which are in the same phase. That is, we are calling the wavefront. So here, wavefront carries the energy. High is the intensity, means energy is also more. But that is the fail. Here, second one. According to the wave theory, wave is propagated like a wavefronts. Wavefront carries the energy. So here different wavefront from the single source. This is the spherical source. So here this is the first wavefront, this is the second wavefront, third wavefront, something. So here, if this one carries some energy, second one is also carries some energy, third one is also carries some energy. When this first one incident on the photoelectric metal, when the first wavefront, that one is incident on the photoelectric metal, then bulk number of the electrons at a time emitted. Next, up to this one approaches the second wavefront approaches the metal plate or photoelectric metal surface. Up to then the electrons does not emitted. But here practically what we observe, electrons are continuously emitted and moving towards the collector. This is also wrong one. So try to observe one more time. Wave theory, according to the wave theory, the wave is moving. That one consists of the wave fronts. Here this wave fronts carries the energy. When one wave front is observed, this is the metal surface. When this first wave front is incident on the photoelectric metal, then what happened? Bulk number of the electrons at a time emitted. So after certain time, a little bit time gap, then second one is incident on the photoelectric metal. Second wavefront is incident on the photoelectric metal. Then at a time bulk number of the electrons are emitted. But that is practically what we observe. Electrons are continuously emitted. When radiation is incident on the photoelectric metal, electrons are continuously emitted. This is the second one, second failure. That is the second failure. Yes, just a minute. Yes. Third one. According to the wave theory, sufficient intensity of the light sufficient intensity of the radiation, that one is incident on the photoelectric metal, those electrons, those free electrons, those are gains the energy and those are come out from the metal surface. In case of the wave nature of the light, threshold frequency term, that one does not exist. According to the wave nature of the light, sufficient intensity of the radiation is incident on the photoelectric metal, electrons are emitted from that one. In that situation, that frequency, that is the threshold frequency term, does not exist according to the wave nature of the light. But practically different metals, they have the different stopping potentials, at the same time different threshold frequencies. So this is also wrong one. That is also failure. I am not saying wrong. That is a failure. Next, fourth one. When observe this one, same thing. Previous one only. This is the wavefront, sir. This first wavefront, incident on the photoelectric metal, emission of the electrons takes place. After certain time gap, next the second wavefront, incident on the photoelectric metal, electrons are emitted from it. Third one, incident on the photoelectric metal, electrons are emitted from it. So means in case of the emission of the electrons, that one takes some time gap. But in case of the loss of the photoelectric effect, what is the last law? That is the instantaneous process. Here, this one is does not obey the last one. That is nothing but the, here some time gap is there in between the incidence of the incident radiation and the emission of the electrons. Some time gap is there. Here some time gap is existing. Some time gap is there. But practically what happened? That is the instantaneous process. This is also failure. So try to observe. First one, intensity of the incident radiation is increases means energy of the radiation is increases. When energy is increases means energy is increases. So means different electrons, they have the different kinetic energies. Means different intensities of the light, they have the different kinetic energies. But practically what we observed, so different intensity of the light, they have the same stopping potential. Means all the electrons, all the emitted electrons, they have the same kinetic energy. Second one is the wavefront. Here in case of the wavefront carries the energy. When this one is incident on the photoelectric metal, bulk number of the electrons at a time emitted. Bulk number, more number of the electrons at a time emitted. But practically that is not happened. Next one. For third one, sufficient intensity of the radiation is incident on the photoelectric metal. Sufficient intensity of the radiation, that is incident on the photoelectric metal. Then what happened? So yes, in that situation, electrons are emitted from it. But observe here, for different metals, they have the different threshold frequencies. In case if this one is right, threshold frequency term does not exist. Practically threshold frequencies exist for different metals, they have the different threshold frequency. So this is also wrong one. Next, fourth one is the some time gap is there due to the wave theory, wave nature of the light. But practically there is that one is the instantaneous process. That is the instantaneous process. Okay. This is about the failures of the wave nature of the light. Failures of the wave nature of the light to explain about the photoelectric effect. So remaining concepts we will discuss in the next video. Okay, bye all of you.